Hi, my name is Emily Miller, and I did my research on a spectrum of antimicrobial activity of 3,4-dihydroquinazolone compounds. So bacteria is constantly mutating and developing resistance to antibiotics, which is an increasing concern. New compounds are needed to fight off resistant bacteria, and a major bacterial target for the cell wall, or is the cell wall, which consists of peptidoglycan layers of different thicknesses, depending on whether it is gram-positive or gram-negative. 10 3,4-dihydroquinazolone compounds, which have inhibited the growth of Staphylococcus aureus during prior research, will be evaluated during this study to see if they could inhibit the growth of both gram-positive and gram-negative bacteria. This research will determine if these compounds exhibit broad-spectrum activity or are specific to certain bacterial strains. Sterile Mueller-Hinton broth was prepared and used to grow broth suspensions of bacteria. Serial dilutions were also created in order to analyze the compounds at different concentrations and how they would react with the bacteria. The plate created as shown on this poster, and it was incubated at 37 degrees Celsius and allowed to grow overnight before reading the absorbances. All absorbances were read at 625 nanometers. And then the data from that was analyzed using SoftPro Max software as well as GraphPad Prism software, where IC50 values were determined. So from the results, there were 4 compounds that inhibited bacteria, 3 of which were in the gram-positive bacteria, which was E. faecalis, and then 1 of which was a gram-negative bacteria. The IC50 values, which is the half maximal inhibitory concentration, they were calculated using GraphPad Prism software. This value determines the amount of compound needed to inhibit and reduce bacterial growth by 50%. So like I said, 3 compounds inhibited E. faecalis, while 1 compound inhibited P. aeruginosa. The data shown in Figure 1 demonstrates that E. coli, Abomani, and P. aeruginosa were not inhibited by the compounds, besides the one exception of TW1139. Overall, 10 compounds were screened throughout the study against 4 different bacterial strains. Because the only other inhibition of bacterial growth was exhibited by gram-positive bacteria, it is plausible that these 3,4-dihydroquinazolone compounds target cell wall biosynthesis. Since these compounds are affecting gram-positive organisms, there may be numerous individual biological targets of these compounds. Particular structural features of individual molecules may be exploited to target different microbes. I would like to thank Selena Malcolm for her work with the 3,4-dihydroquinazolone compounds. The results from her research with S. aureus is the foundation of this study. I would also like to thank Dr. Mosey for advising me and Dr. Hutchins for helping me in the laboratory. Thank you.